Assalamualaikum everyone. In this video, I'm going to explain on how to answer the example 5.14 under the subtopic Kirchhoff's law. So here we have a circuit diagram. From what we can see, this is a complex circuit. It has more than 2 batteries at different wire. And then we have 4 resistors right here. What we need to do first is label all the batteries and the resistor and also the current. So for the batteries, let's say this is EMF 1, this is EMF 2. Meanwhile for the resistor, this is R1, R2, R3 and R4. Why do we need to label? Because it will make easier for us to write the equation later. And then for the current, let's take this junction. So here we have I2 and then I3 and here we have I. You can choose either you want to use the upper junction right here or the lower junction right here. You will get the same equation. So we have labeled all the batteries, resistor and current in this circuit diagram. First, let's apply the Kirchhoff current law or KCL, where summation of current into the junction equal to the summation of current out of the junction. Let's say I choose the junction up here. So the current that into the junction is I and also I3. So I label it as I plus I3 equal to current that out from the junction is I2. In this equation, we already have the value for I, which is 2.5 ampere. So we can substitute into this equation. 2.5 plus I3 equal to I2. This will be our first equation. Next, let's do KVL or Kirchhoff voltage law for the first loop. And for this loop, since the question does not give whether it's clockwise or anti-clockwise, so it's up to you. Okay, you want to do it clockwise or anti-clockwise. So for this example, I want to try to make it clockwise. So KVL is summation of EMF equal to the summation of IR. So for the first loop, there are 2 batteries. For EMF 1, the loop will pass through negative terminal, then it will go to the positive terminal, so positive EMF 1. Meanwhile, for the second EMF, the loop will pass through negative terminal and then it will go to the positive terminal, then it will become positive EMF 2. For the resistor, there are 3 resistors in this loop, R1, R2 and R3. So for the first resistor R1, current that flows through R1 is I. This 2.5 ampere flows through R1. So I write it as I R1 and let's check whether it's positive or negative. The current I will flow in this direction, so it has the same direction as the loop. So it will be positive sign. For R2, current that flows through R2 is also I, here, the same current, and the direction is the same as the direction of the loop, so it will be positive I, R2. What about R3 right here? The current that flows through R3 is I2, and if we compare with the direction of the loop, it has the same direction. So, positive I2, R3. Okay, current that flows through R3 is I2, so we need to label it as I2. Okay, what are the values that we have? EMF 1 is unknown. EMF 2 is 24 volt. I is 2.5 ampere, meanwhile R1 is 5. So we actually can find the value. 2.5 times with 5 plus with IR2, which is 2.5 ampere times with 6 ohm plus with I2 R3. I2 is unknown, meanwhile R3 is 8, so we can write this as 8I2. When we simplify the equation, we will get EMF 1 equal to 3.5 plus with 8I2. Okay, this will be second equation. For the second loop, loop 2, I want to make it the loop as anti-clockwise. So what happened to the EMF? If the loop is anti-clockwise, it will follow this direction and it will pass through negative terminal and then positive terminal. So EMF2 will be positive, equal to, there are two resistors in loop 2. So let's see R3 first. The current that flows through R3 is I2. So the direction of I2 is the same with the direction of the loop. So it will be positive I2 R3. What about R4? Current that flows through R4 is I3. And it has the same direction with the loop. So it will be positive I3 R4. Okay. EMF2 is equal to 24. I2 is unknown. R3 is 8. R4 is 5 ohm. Meanwhile, I3 is also unknown. Then we will get this equation. Okay, now we can solve for the unknown by using simultaneous equation. So you can use your calculator. For the first equation, I write it as this one. I2 minus I3 minus 2.5 equal to 0. And from the second equation, let's write it as EMF1 minus 8I2 minus 3.5 equal to 0. And then for the third equation, okay, we can write it as 8I2 plus 5I3 minus 24 equal to 0. So by using your calculator, solve for the unknowns, then you will get the final answer as I2 equal to 2.81 ampere, I3 0.31 ampere. Meanwhile, for EMF1, we will get 25.98 volts. Okay, when you have this kind of equation, please make sure that you write the equation for KCL and KVL. And then if you have 3 unknowns, you need at least 3 equations. So you have equation 1, equation 2, and equation 3. Please also write this equation for each loop so that you can check again your equation based on the diagram or the circuit. Okay. So what if you want to use manual calculation instead of using calculator? Okay, dia akan ambil masa yang lama. Then you can be very careful, avoid careless mistake. Okay, so I will show you the example if you want to solve it by using manual calculation. So we have the equation for KCL, equation 1, for loop 1, and for second loop. Okay, we have 3 equations right now. So this is the example. Okay, it's up to you whether you want to choose which equation and substitute into which equation. So what can we do is, from the first equation, we rearrange it, become like this, I3 equal to I2 minus 2.5. And then we can substitute this equation into equation 3. Okay, you substitute here. And then expand the equation. From here, we can directly get the value for I2. Next, from I2, we can substitute it into equation 2. Then we will get EMF 1. And the last one, since we already have I2 and also I, we can substitute the value into equation here, equation 4. Then you will get I3. So that's the final answer for the unknown values in this circuit. Since all the values of current are positive, thus the direction assigned in the circuit is the actual direction. So at first, maybe soalan ni pun dia just assume sahaja the direction of current. But at the end, we'll get all the values for current are positive. So inilah arah sebenar current in this complex circuit.